欢迎大家来。然后我的基金会的同仁是规定我有一些事情一定要是做报告的，所以请原谅我这个 routine 是一定要做的。首先呢，我们都知道说任何在舞台前所推出的好的东西，幕后其实都是有很多人在工作的。所以我今天在这里呢，也是在第一件事情就是要特别谢谢好多人在基金会后面给我们大的协助。这一次当然我们这个国际名家系列全部都是由联发科它的独家赞助才可能。那另外就是尤其这一次把 Dr. Church 从澳洲请来呢，在澳洲商务办事处，他是我们的合伙的同伴。那同时在整个过程里头，特别要谢谢是像中广、ICRT、IC 之音，那尤其是中华电信、科学人杂志、雅都饭店、中央大学的地球科学院。以及成功大学都是我们大家工作的伙伴。大家也都知道，这个基金会呢是由董事们，但所有的董事，包括我自己，都是义工。然后只有4位专职的同仁在工作，带着几百位的志工，大部分是大学生，在做所有的细节的安排，包括大家手上所有的这个手册，也都是志工先去研究议题，去找资料，做判断，有很多时间的讨论，还要注意它中文跟英文的翻译做出来的手册。所以我还是要利用这个机会说，我们要鼓励我们的年轻人，除了在课堂里头学习之外，也走出他的教室来参与社会的改革。所以我像惯常一样，我们都给我们的工作的志工给他们一点掌声，谢谢他们。那我们今天也特别有几位贵宾来到这里，所以我也想让大家知道说有哪一些贵宾今天特别来到这里，是来表示对这个议题的关心。我们有交通部的常务次长陈威仁陈次长在这里 ，Thank you so very much。陈威仁 is an old colleague of mine, and he's now the Deputy Minister of Transportation. It's a department closely in association with environmental issues as well. We also have the former ambassador to Burkina Faso, Mr. Gong Zhengding大使. Thank you so much for coming. And we also have the Deputy Minister of the Department of Urban City Development of Taipei City Government. Dr. Bian is here. Bian 副局长，谢谢你来。And very specially, we also have the university presidents from 2 universities. That's Dr. Chen Haidong from Donghai University. Thank you so very much for coming. Chen Haidong. And Dr. Peng Zongping, the president of Yanzhi University. Peng 校长, thank you. Then I shift to Chinese again. 所以所有今天来到这里的朋友，也特别请你们注意一下，除了今天的手册之外，你看一下啊，你们可能后面看不到的是，我脚下面坐了一整排高山女中的学生，你们探出一个头来给大家打个招呼好不好？高中生。我想说，在这样一个坚硬的、严肃的议题，而且我们也知道，通常媒体是比较容易去完全被眼前的看起来很大的议题所牵着走，但是一个有知识的、有定见的社会知道说，whatever is urgent may not be important. Whatever is important may not seem so urgent. And a wise society knows what the difference is between the two things. OK， 所以我们基金会会推出这样一个议题，而且在这个过程里头非常的开心，看到媒体的重视。我们昨天Dr. Church 到成功大学也特别做了一次的演讲，反应非常的热烈。所以我们所有的工作的同仁都觉得， 也许这个社会也不是我们所想象的那么的没有远见，关心这个严肃议题的人可能比我们想象的要多得很。那尤其是今天10几岁的时候，高中生在老师的带领之下也会来关心这个议题的话，我觉得就是高中生他提早了看到教室以外的东西，你就提早去身体力行去实践，对影响真正对社会有影响的真正的可以实践的议题，先锋的议题的参与非常非常的好。那我想鼓励今天来到这里的人，也把我们基金会在做的事情，让更多的人知道。所以你可以加入我们的团队做志工，就是跟我们同仁联系。那如果你不是有时间的人，可是你有钱，那很欢迎你做 donations anytime，OK？所以这个基金会它基本上就是台湾社会的文化力量的展现。我们不收任何政府的钱，我们完全向民间募款所以有时间的，请你捐出时间给我们。那么有金钱的捐金钱，如果你认为我们在做的事情对台湾的发展是重要的话，尤其是年轻人，我想特别你要注意一下，丝沙龙4个系列就开始了。在这个丝沙龙的4个系列里头呢，您注意看4个大名家不要错过，4个举足轻重的经济学家，用他们的独特的眼光，从全球化的这个大趋势里头去看很多会影响我们的社会，影响到我们每一个人生活的未来。因为社会结构、价值结构、经济结构跟政治结构都在转变中，我想我们可能应该早一点认识到未来的世界是什么样一个状况。我常觉得像李鸿章在19世纪末的时候，他就会发现到说有数千年没有经过的大变局来到了他那一代。我想我们今天这一代其实也是面临一个大变局，所以大家早一点做准备。所以丝沙龙的这个系列，请大家赶快报名。And finally, I want to say, I want to thank Dr. Church so very much for making the time to come here. This is his first trip to Taiwan, and I'm sure, and I hope it's not going to be the last time. And I hope both the audience and the colleagues who are working with you have made an impression on you that this is the place that worth getting to know. 但接下来呢，这整个场的主持跟之后的问答，我们都邀请了，就是我自己觉得是全中华民国最佳的主持人的《科学人》杂志的总编辑是李家维教授。那我也希望今天在场的朋友们呢，因为今天这个议题它有很深的这个知识上的挑战，再加上翻译，所以如果英语它其中有很多的名词您不是抓得很紧的话，真的是用耳机那最后的 Q&A 呢，因为我相信李家维在台上的话，一切都可以掌握得很好。我们现在就用真的是最热烈的掌声欢迎这个主持人今天李家维博士，好吗？
大约在50、60年前，台湾的渔民在台湾海峡作业，捞起了数以百计的死骨头。他们认为这些是不吉祥的东西，所以大多数就丢在澎湖各个小岛上头的庙宇边上。这样子的消息逐渐泄露出去了。日本的化石收集者、日本的化石的爱好者就纷纷的拥有了这一批重要的收藏。自然科学博物馆的工作人员，我们的古生物学家也开始大量的委托渔民去采集这些来自于海底下的死骨头。大家很容易的认出来，这些是古老的哺乳动物，所以台湾没有很好的背景的科学家参与过这样子的研究工作，就邀请了中国科学院北京的古人类与古脊椎研究所的专家，他们来了一群人，在台中自然科学博物馆待了半年，把这些骨头给组合在一起，然后鉴定出他们的身份。最后他们提出了这么一个动人的说法， 说至少在2万年前，台湾海峡是裸露出来的，有成群的大象、鹿、水牛、马，还有其他的各式各样的哺乳动物在这个地方活动，而且其中有一个鹿的骨头，它的头角上头还被石头给割出了一道刻痕，代表台湾人的祖先曾经跟这群动物住在一起。他们来自于中国大陆的华北，在台湾跟华北之间做季节性的迁徙。这就好像在非洲我们可以看到 Serengeti 草原上头那些伟大的迁徙过程是一样的。现在我们很清楚，在过去的200万年里头，世界上经历过至少20次的冰河期，每一次有10万年之久。最后的一次在2万年前达到高峰，那一次全球的冰封让海水下降了大约120公尺。我为了这件事情带了2个骨头，让大家亲手摸一摸。这一块是半颗大象的臼齿，这是一头巨大的大象，它一辈子的第6颗牙齿。它记录了一个至少40-50岁以上大象的骨头。我这里带了一个已经灭绝的德氏水牛的脚，大家传着摸一摸，你感觉一下子，也想象一下子，在2万年前他们是怎么生活在台湾海峡里头。那时候这是个路桥。如果我们现在的地球按照过去200年的韵律的话，我们应该逐渐地走进一个新的冰河期，但是显然没有如此。原因有很多，其中有一个甚至说是因为中国人在长江开始种水稻，水淹没了稻田，然后水稻田里头的甲烷气让地球逐渐升温。但是大家更知道的就是我们工业化以后所造成的结果。全球暖化带来了全球的不安，我们在去年才经历过从来没有预期也没有想象过的那么大的一个灾难。最近这2个月，我们正在担心的是，台湾北部的水库是不是耐得起在今年夏天如果来那么一场大雨的话，它能够安全吗？往后还有很多的顾虑。面对新的挑战，我们需要大量充实正确的知识，我们需要有建议，我们需要有信心来面对将来的困难。这也就是这一次邀请 Dr. Church 来这里的原因。Welcome, the Master of Sea Level, Dr. John Church.
Thank you very much for that very kind introduction. Before I start to talk about a subject which I've become rather passionate about in recent years, I should firstly like to thank the Lung Yitai Foundation, and particularly Madam Lung, and also Li Yingpeng for inviting me here and actually making this visit happen, and also the Australian Commerce and Industry Office, Alice Court, Richard Matthews, and Lauren Hu, who helped so much in getting me here. So today I'm going to talk about sea level rise, why it's important for us, some understanding of it, what we might expect in the future, and what we might need to do in response to it. The introduction, I'm going to give you a little bit of motivation and set some scene for the context of what I'll talk about subsequently. Then I'm going to talk a little bit about how we actually observe sea level change, how it's changing, and why it is changing. Then I want to look into the future and say how it might change both during the 20th century and the 21st century and beyond. What are the potential impacts and how we might have to adapt to changing sea levels. And finish with a summary. So to give you some context, this shows a picture of, on the top graph, sea level over the last 140,000 years. if you go back to the last ice age, about 130, the last interglacial period, about 130,000 years ago, at that time sea level was higher than it is today, perhaps 4 to 6 metres or more higher than it is today, so a substantial difference. And coming into that period of high sea levels, rates of sea level rise were high. 1.5 metres per century is one estimate. And both of these factors occurred at temperatures that we expect to experience on the Earth later this century. So this is perhaps a first lesson from history that maybe we should be expecting higher sea levels later this century. Then moving into the last glacial maximum, sea level fell by over 120 metres and then rose rapidly at rates of 1 metre per century for many millennia, and perhaps with peak rates of 2, 3 and perhaps even 4 metres per century. And after about 7,000 years ago, sea level largely stabilised, and over the last 2,000 years, from about 2,000 years ago to about 1800, there was essentially very little global change in sea level. And it's during this period of stable sea level, that our coastal society has developed. And this has allowed us to build right up to the coast and enjoy our coastline. This shows one example of the very rapid development of the coastline that's occurred over the last 50 years. In this case, it's the Gold Coast in Australia. The top picture is taken about 1960, and the bottom picture just a few years ago. In this period, the population has increased by more than a factor of 10. That's the permanent population in this region, has increased by more than a factor of 10. And that's quite evident from the change in nature of the coastal infrastructure that you can see in these two pictures. And of course, in addition to that, there's a very large transient population of tourists coming through this area. But this is not the only example. You can look around the world at many places where we've greatly developed the coast in the last 50 years. So if sea level's changing, what might be the impacts? What sort of things do we need to think about looking into the future? And it's not just the mean rise in sea level, it's a combination of sea level rise and extreme events. So these are storm surges, hurricanes, etc. This combination, how could it impact our society? Well, of course, the first example is inundation, whether that's in modern cities like New Orleans on the bottom left, or in Pacific islands like on the top right-hand corner. This is actually a picture of the Met Office in one of the Pacific islands on a high tide situation. Not a particularly high flooding situation, but a regular occurrence in this region. The storm surges and waves and their impact on coastal infrastructure, houses, jetties, wharves, roads, etc. There's long-term erosion issues impacting on houses. Shown in the bottom left is a picture from the US. On the top right, another picture from the US of a house fallen onto the beach because its foundations have been undercut by coastal erosion. Pictures in Africa. And then the bottom two pictures on the right are a pair of pictures taken less than a decade apart, showing rapid coastal erosion occurring in the UK. We also need to think about the impact on emergency and escape routes when we plan our cities of the future. These pictures are from New Orleans, from people who are actually trapped because there was no way out when the levees broke. So we need to think into the future and how we might plan our cities to prevent this sort of situation occurring. Environmental refugees is a major issue. It's occurring now, it will occur in the future, and it'll be a growing impact. There's no international convention on environmental refugees, but it is a humanitarian situation which we will have to deal with. It's not if there will be major issues, but where they are going to occur, when they're going to occur, and how will we respond, and what are our responsibilities. And there's associated issues of food and water security, health, poverty, and all those flow-on effects that come when our normal life is disrupted. So how do we observe sea level change? I'm just really going to focus on the last couple of thousand years and really on the last 100 or 200 years. Shown in this first picture is a photo of fish tanks in ancient Rome. So these were fish tanks which were built at sea level, and the bottom right-hand corner, can't quite see it for the light in the way, but the bottom right-hand corner shows the sluice gates which allowed water to flow into and out of these fish tanks. So clearly these fish tanks had to be built at sea level. This is one type of evidence you can use, paleo evidence that you can use for estimating historical sea level. And what it shows in this case is that there was little net change in sea level from roughly 2,000 years ago until about 1800. Again, that's a period when our coastal society has largely developed. Here's a couple more examples. A picture of a well which is now submerged off the west coast of Israel from 8,200 years ago. Some bronze carvings in southwestern Sweden which are now underwater. And something that you use for looking at the longer time scale. These are coral reef terraces. These lines along here are coral reef terraces from the Huon Peninsula in New Guinea, which you can use to, after allowing for the land motion, to estimate historical sea levels. These days, of course, we measure sea level by coastal tide gauges, coastal sea level measurements, whether they be in Antarctica, in Venice with St. Mark's Square in the background here, on a Pacific island, and these are two modern instrumentations, but a critical part of all of these instrumentations was relating the sea level back to a vertical, a permanent benchmark on the land so that you can relate sea level changes over long periods of time. And of course, the most modern method of measuring sea level is by satellite. This instrument here, a series of satellites which started in late 1992, really started producing data in early 1993. And these are really remarkable instruments which measure the sea level via satellite by sending a laser pulse down from the satellite which bounces off the surface, or a radar pulse, and back to the satellite. You measure the transit time. You need to make some corrections for the amount of water vapour and the air pressure below the satellite. And then you can actually measure that distance from the satellite to the sea surface. If independently, you also measure the position of the satellite via laser ranging technology or GPS satellites, then you can actually determine what the position of the satellite is, and therefore what the position of the sea surface is relative to the surface of the Earth. We have a series of these satellites now from 93. Topex Poseidon was the first satellite. Jason 1 and Jason 2 are both flying at the moment, and we have promises for a third satellite to continue this series of sea level measurements. So what do these measurements tell us? These show several examples of sea level measurements from around the world. The earliest sea level measurements from coastal sea level measurements comes from about 1700 in Amsterdam in Europe. What's interesting about all of these early graphs is they all curve up towards the right. an increasing rate of sea level change, particularly coming into the 20th century compared with the 19th century. And the same signal is present in all of these long records that we have available to us. And what my group has really done is to combine these historical measurements of coastal sea level with satellite observations of sea level to determine an estimate of global average sea level over the period from 1850 in this case up to the present. And what we see is that the rate of sea level rise has increased from the 19th to the 20th century. It's increased again during the 20th century, and since 1993, the upper part of this curve, when we've had satellite measurements, both satellite and land-based measurements, coastal sea level measurements, indicate that the rate of sea level rise since 1993 is approaching twice the average for the 20th century. So a significant acceleration in sea level rise over this period from 1850 to the present. The satellites give us global measurements for the first time, and they clearly indicate that over this period the rate of sea level rise has not been uniform over the globe. A much larger rate of rise in the Western Pacific, perhaps 3 times the global average over this period, and perhaps even a slight fall in sea level in the Western Pacific. So of course Taiwan is just north of this major region, but in a region above the global average, at least over this period. But this is not a stable pattern. This is primarily a pattern associated with climate variability, particularly interannual climate variability associated with the El Nino Southern Oscillation phenomena, which brings drought and floods to Australia, and I presume it also is a strong influence on climate, interannual climate variability in Taiwan. So why does sea level change? The first reason, and perhaps the best understood of the explanations for changing sea level, is ocean warming. Just as with a thermometer, if you warm the liquid in a thermometer, the level in the thermometer rises. So if you warm the oceans, the water in the oceans expands and sea level rises. And we can measure that warming by several different techniques. On the bottom here is shown a series of floats which are deployed into the ocean. They sink to a depth of about 1,000 metres, drift at depth of 1,000 metres for the order of 10 days, sink down to 2,000 metres, and then rise to the surface, measuring the temperature and salinity of the ocean, and transmit that data via satellite back to Earth, back to ground stations, and then repeat the cycle. And there's a whole array of these instruments measuring the upper ocean heat content, or the amount of thermal expansion or sea level rise resulting from that warming ocean. On the top, just showing the deployment of one of these instruments, and we can also lower instruments from research ships to measure temperature changes throughout the water column. So sea level rise from warming of the ocean and thermal expansion is a critically important element. Just to give you some idea of where the heat is going associated with climate change, if you want to understand climate change, it's all about the heat content of the Earth's system. The bars here represent the amount of heat observed from 1960 in the top blue bars and 1993 in the bottom red bars up to 2003 for the various elements of the climate system. The oceans are up the top. Then in comparison, glaciers and ice caps, the amount of heat required to melt glaciers and ice caps is essentially negligible compared with the amount of heat that's stored in the ocean. Similarly, melting the Greenland ice sheet, the Antarctic ice sheet, the amount of heat stored in warming the continents, the amount of heat stored in the atmosphere, and melting Arctic sea ice, these are all essentially minor components compared with the amount of heat stored in the ocean. So if you want to understand climate change, you really need to understand how the oceans are changing. One of the interesting things we found out along the way is that these violent volcanic eruptions, like this eruption in Mount Pinatubo in the Philippines, are an important aspect of understanding climate and of understanding the oceans. These volcanic eruptions eject sulfur into the stratosphere at heights of 20 kilometers or more. The sulfur turns into aerosols. The aerosols reflect some of the solar radiation and therefore cool the Earth. There's interesting implications for here from this finding that if you want to cool the Earth artificially, then maybe you could consider injecting aerosols into the stratosphere. And people are actually talking about these ideas. And what we actually notice when we look at the time series of ocean heat content, this is our time series in black here, and on the bottom are the major volcanic eruptions of Mount Agung in Indonesia in 1963, El Chichon in Mexico in 1982, and Mount Pinatubo in the Philippines in 1991. And following each of these eruptions, the surface temperature of the planet cooled, the heat content in the ocean cooled, and sea level fell slightly. Can we just have the one of... Thank you. The second major contribution to sea level rise is the melting of glaciers. So these are glaciers in places like Patagonia, Alaska, the Himalayas, and as this example shows, in Europe. The picture on the left is from 1900, shows the Rhone Glacier descending down this valley to just behind these buildings. Virtually no vegetation on the hillside, no trees in the valley, and quite a considerable stream of meltwater running off this glacier down towards the ocean. The second picture, taken roughly 100 years later in 2000, the same buildings are there, but the glacier has essentially disappeared from this picture. It's retreated well back up the mountain to just the very highest peaks of this mountain. The vegetation has also changed. There's now trees growing in the valley, growing up the hillside, and the stream, which previously carried considerable meltwater, has dwindled to a trickle. But what are the really big questions about future sea level rise? And that they're related to the two ice sheets, the ice sheets of Greenland. Greenland is essentially a relic ice sheet from the last ice age. The red area on this curve is the area of surface melting in 2005. And the time series in the bottom left shows a time series of the area of that surface melt from the start of the satellite observations in 1979 to the present, and shows a clear increasing trend on the amount of surface melt coming off the Greenland ice sheet. It's a significant contribution to sea level rise and potentially a major issue coming into the future, and we will revisit that later. Here's an example of the meltwater, a pond of water that's accumulated on the surface of the Greenland ice sheet. And this meltwater runs off into the ocean. In this case, it's running off down through a hole in the ice, what's called a moulin, taking the water down to the base of the ice sheet, lifting the ice sheet off the bedrock and allowing it to slide more rapidly into the ocean. This phenomenon has been observed. There's been observations of a flow of water down one of these moulins equivalent to the Niagara Falls, so a very large flow of water. While this does help the ice sheets to slide more rapidly, it's not the dominant effect, and we will revisit what the dominant effect is shortly. If you look at the thickness of the Greenland ice sheet, then all the blue areas around the edge here are areas where the ice sheet has thinned over recent years, both as a result of the melting, perhaps more importantly, the result of a faster flow of glaciers from the ice sheet into the ocean. This same process is also occurring in Antarctica, particularly the West Antarctic ice sheet. So that's this region over here, and all this region in red is where there's been a significant thinning of the ice sheet over recent years. Glaciers are flowing more rapidly into the ocean. You can measure the thickness of the glaciers. You can measure the gravitational changes associated with the change in mass of this West Antarctic ice sheet. And you can actually also measure the velocity of these glaciers flowing into the ocean. All of these indications are a growing contribution from what was previously thought of as a slumbering giant of the Antarctic ice sheet. There's really two components to the Antarctic ice sheet. The West Antarctic ice sheet, which is showing this considerable dynamic response, sliding of the ice, the glaciers in the West Antarctic, and then the East Antarctic ice sheet, which is much higher and much colder, and to this stage, much stabler. The West Antarctic ice sheet is actually grounded below sea level. This allows warm ocean water to penetrate under ice shelves, warming the ice sheet at its base and freeing it of the topography to flow more rapidly. And a result coming from here in Taiwan, from Ben Chao, one of the additional contributions to understand 20th century sea level rise is how much water is stored on land. So during the 20th century, we've built a large number of dams and terrestrial storage reservoirs around the world, peaking probably in the 1970s, and the total amount of water accumulated in these reservoirs from 1900 up to the present is about 23 millimetres of equivalent sea level. So if it wasn't for this water storage, the building of dams in the terrestrial regions, then sea level would actually be higher than it currently is. In addition to the actual water stored in the dams themselves, some of the water sinks into the surrounding sediments. So in total, the amount stored is equivalent about 30 millimetres or 3 centimetres, and if it wasn't for this effect, sea level would be higher by about that amount. In addition, of course, we're actually taking water from aquifers, mining groundwater, we're using that for irrigation, we're using that for our cities, and eventually that water flows off into the ocean. If we add all those components together, then we have an approximate explanation for why sea level has been changing from 1960 to the present. Shown in the blue curve in this graph is our estimate of sea level change over that period from 1960 to the present, and the red curve shows the sum of all those contributions that I've just talked about, and we notice that they're in pretty good agreement, in fact, with the observations of sea level change over this period from 1960 to the present. This represents significant progress since the last two IPCC reports when they were unable to explain adequately anyway, the observed sea level rise. So now I'm going to move on to what will happen, what we expect to happen in the future. Shown on this graph is the projections of sea level rise from both the third IPCC assessment and also the fourth IPCC assessment. The third assessment is shown by the shading and the solid lines, and the fourth assessment by the bar plotted at 2095. And these measurements are compared with 2090. The bottom part of the bar is principally from warming of the oceans and the resultant expansion of the oceans and the melting of non-polar glaciers, with smaller contributions associated with changes in snowfall and surface melting of the Greenland and the Antarctic ice sheet. And that's roughly a 20 to 60 centimetre rise by 2100. However, in addition to that, we know the ice sheets are sliding into the ocean. We've seen evidence, multiple lines of evidence for that over recent years. We don't have good models of this process as yet. We have some rudimentary understanding. We have models of individual glaciers, but we don't have models of the complete ice sheets. So there was a crude estimation of what the contribution from the ice sheets could be, and it was up to about 20 centimetres by 2100. But it came with a caution that we cannot exclude larger values. And so this implies a sea level rise of anywhere between about 20 and 80, perhaps 90 centimetres in these IPCC projections by 2100. If you look, where has sea level been going since the start of these projections, which start in 1900, then we actually note that sea level is observed to be tracking along the upper edge of these projections. So it's this line here, which leads to a sea level rise of about 90 centimetres by 2100. That's not to say we will continue to track that upper limit, but it is a caution. We could diverge either above or below that upper limit, depending on particularly the behaviour of the ice sheets, and also decisions that we as a society make as to how much greenhouse gases we emit into the atmosphere. Next slide. Thank you. So what might be the longer term implications? This is a graph plotting sea level on the bottom axis, on the x-axis, versus carbon dioxide concentrations. So we're here at this red dot, or we were in pre-industrial times, at zero sea level and CO2 concentration of about 280 parts per million. The last ice age, we're right over on the right, with sea level something like 120 metres or more below present-day sea level, at CO2 concentrations of about 180 parts per million. So where are we now? Current day carbon dioxide concentrations are increasing. They're about 380, 390 parts per million now, increasing about 2.5 parts per million per year. If you read off the graph where this might imply sea level could be, it's about 10 metres above current day values. And if you realise there's not only carbon dioxide as a greenhouse gas, there are several other greenhouse gases, then our effective carbon dioxide concentration at the moment is about 450 parts per million, and that's a somewhat larger sea level rise. Now this is not a mechanistic understanding of what could happen, but it is a warning from history about the potential for significant changes in sea level. So how does this happen? Firstly, the oceans have very long time frames to adjust. The top right-hand panel shows various greenhouse gas scenarios which have carbon dioxide and other greenhouse gases increasing until 2100 and then levelling off. We somehow stabilise the atmospheric concentrations of greenhouse gases. When that happens, temperature almost stabilises, not quite, it continues to rise slowly for several hundred years, but sea level in the bottom curve hardly notices the change in, or the levelling off in carbon dioxide concentrations in the atmosphere. Sea level will continue to rise for centuries as a result of the long timescales associated with the oceans. And of course, if we Thank you. Of course, if we just stabilise emissions, then the rate of sea level rise will be even larger. The Greenland ice sheet is a critical issue. The surface melt is increasing. If we get to a 3 degrees Celsius warming above pre-industrial temperatures, a temperature we could well exceed this century, then surface melting alone exceeds the snowfall on Greenland. That means an ongoing and long-term decay of the Greenland ice sheet, leading to a sea level rise of metres. This is a relatively slow process, but we could pass that threshold this century. Once we're past that threshold, we're unlikely to reverse it, and we could be committing future generations to sea level rise of metres. An even more important process for the 21st century, besides surface melting, is the increased sliding of the glaciers into the ocean. This is a schematic representation of an ice sheet, both the Greenland ice sheet and the Antarctic ice sheet. You have snowfall accumulating in the centre of the ice sheet, and that flows out to the ocean as ice streams, eventually decaying and icebergs carving off into the ocean. If you warm the ocean and that warm water penetrates underneath the ice shelf, it can melt the ice shelf at its base, melts it more effectively than surface warming. It can float the ice sheet free of any topography on the ice shelf. Warm water penetrates further back, melts the ice sheet at the grounding line, which moves backwards. These phenomena allows the ice sheets to flow more rapidly into the ocean. We believe this process is happening both in the Greenland ice sheet and in the West Antarctic ice sheet today, and it will continue to happen during the 21st century. This shows the results of one of those. This is the Jakobsværnesbree Glacier in West Greenland, one of the largest glaciers draining Greenland. And you see the many large icebergs flowing out of this Greenland at an accelerated rate as a result of this process. So what are the potential impacts and what are our adaptation options? There are many regions around the world that are particularly vulnerable to changing sea levels. If you consider the Bay of Bengal for a start, then there's been a whole series of storm surges in the Bay of Bengal that have resulted in major loss of life. As recently as 1991, for example, 140,000 people perished, 10 million people were made homeless essentially overnight. Since 1737, there's about 23 surges which have killed at least 10,000 people. There are other regions, of course, of the world where similar impacts are felt. Only a few years ago, Myanmar had a storm surge where about 140,000 people died and many millions were made homeless. This is a picture from the UK, from Europe, actually the pictures from UK from the 1953 storm surge, when over 2,000 people lost their lives in Europe and several hundred lost their lives in UK. So it's not just the developed or the developing world at risk. There's potential regions of risk right around the globe. Next one, please. So what is our current exposure to sea level? Shown here is an estimate of the area that's potentially vulnerable to inundation, the population, and the gross domestic product as a function of distance above mean high water level at the present. So just focusing on this 1 metre value and going down to the table and reading them off, approximately 150 million people live within 1 metre of present high water level. Roughly $1 trillion of gross domestic product are generated in that first metre above high water level. 1 metre is the amount of sea level rise at the upper end of the projections, which is potentially going to occur this century. So these are large numbers which would have very significant impacts on our society. If you look around the world, many of the megacities of the world, these are cities with populations of 8 million or so, and in some cases very much more, are located right on the coastline. Many of these cities are actually located on deltas. If you think about places like Dhaka, the deltas themselves are sinking. It's not just that sea level rise. The deltas are compacting. The sediments on which these deltas are built are compacting. As we extract groundwater from the deltas for use in irrigation and in our cities, the sediments compact even further. So these coastal cities are having this twin impact of falling land and rising sea level. Extreme events impact us now, of course. This is a picture from Galveston in the USA showing a storm surge flooding through the city. These events impact us now in many places around the world. And back one. This is another example. This is Venice. This is usually a place where people can walk. But here's a surge. As you can see, it's actually relatively fine weather. But people are having to walk along these tables put out between buildings rather than walk on the normal footpath. These events are already, or have already during the 20th century, increased in frequency such that it's becoming more and more difficult to live in Venice. So Venice is actively planning to build barrages to stop the storm surges entering the Venice canals. We've looked in Australia and we've looked at the 20th century record of sea level. If you look at both Sydney on the east coast of Australia and Fremantle on the west coast of Australia, these two locations with long sea level records, then what we find is during the 20th century, if you compare the first half of the 20th century to the second half, then sea level events, coastal flooding events of a given magnitude have already increased their frequency by a factor of 3. If you look into the future and say, what will that mean for 2100, then what you find is that for events that are currently a rare flood, what's called a 1 in 100 year flood, so this is an event that you would normally expect to occur once every 100 years, by 2100 that event is likely to be occurring at least several times per year. So what are our options for adaptation? Well, firstly, we need to reduce our emissions if we are to avoid the worst case scenarios. But we will not be able to stop all sea level rise. So we will have to adapt. And there's basically 3 options here. We can retreat from the coastline. We can either be forced to retreat or we can have a planned retreat. And there's an example of that happening in the UK in the top left, where they're actually taking a piece of land and completely abandoning it to the ocean and pulling back from the coastline. We can accommodate for sea level rise as in the middle panel, building our houses higher, for example, and shown on the left is a picture of a storm surge shelter in Bangladesh. So during high sea level events, people retreat to this storm surge shelter, and I believe that these shelters can be attributed to saving tens of thousands of lives in Bangladesh over recent years. Or we can protect valuable coastal regions by building barriers or hard or soft barriers. And there's 2 examples shown on the left. The far left one shown here is the Thames Barrage, which protects the City of London. There's about £100 billion of assets protected by this barrage. Shown in this picture is a flooding event seaward of the barrage, but a few years ago a storm surge came within centimetres of overtopping this barrage. So London is actively, or UK is actively planning to extend the barrage to protect London into the future. And the second picture there is of Rotterdam, who also have a similar barrage. So in summary, our coastal society has developed during a period of stable sea level. It's allowed us to build right up to the coastline. That situation has now changed. Sea level has been rising during the 20th century. It's accelerated from the 19th to the 20th century, during the 20th century. And currently, sea level is tracking along the upper edge of the projections. That's the line that leads to about a metre rise compared to pre-industrial levels. And we know there's significant uncertainties about the ice sheets. So the scientific evidence clearly shows that ongoing sea level rise is virtually inevitable. It's an issue that's going to occur during the 21st century and into the longer term. We're going to need to adapt. Coastal inundation, coastal erosion, impact on the built infrastructure, impact on the natural environment will all be increasing issues during the 21st century. Coastal flooding events will become more frequent and more severe, and of course the least developed nations and the poor are most at risk. And to minimise this risk and to minimise the impacts, local and regional planning is urgent. We're going to need to mitigate, reduce our emissions of greenhouse gases if we are to avoid the most extreme scenarios. Without significant, urgent and sustained reduction in emissions, we'll pass that threshold leading to an ongoing melting of the Greenland ice sheet and committing the world to sea level rise of metres. I believe this is urgent and short-term emission goals are critical. But I think we should be very positive in our approach to this. There are many options that are available to us in terms of reducing our energy use, being more efficient in our use of energy, stopping wastage, using more efficient appliances, more efficient transport mechanisms, developing renewable energies, and capturing greenhouse gases emitted particularly from the burning of coal for electricity. So there are many options, and we should confront this challenging future optimistically. Environmental refugees will be a major issue. There is no convention that governs environmental refugees, but nevertheless it will be a humanitarian issue that we in our society will have to deal with. To minimise costs, we need to reduce uncertainties. There are scientific uncertainties associated particularly with the ice sheets and the ocean. Reducing those uncertainties will minimise costs, and we need to implement early warning systems such that storm surges, people can be evacuated in time. There's no reason why people have to die in hospital beds because they couldn't be evacuated from imminent danger. And to do all these, I think it's essential and urgent that we both develop and strengthen partnerships between science, government, business, and industry, and the community. Much of this work is published in or will be published in a book which is to come out roughly the middle of this year, published by Blackwell's, Understanding Sea Level Rise and Variability, and thank you.
这么大的讲堂还不足以容纳台北的求知若渴的朋友们。刚才有位朋友告诉我，他远从嘉义过来，他是以艺术为职业的年轻人，到台北来听海平面变化的故事。刚才我也知道，在外头还有50位以上的朋友们在那里进不来看的广播。那我在这里先跟你们打个招呼，希望等一下子递纸条进来，我们一起可以发问的。现在我们有许多的问题要请教，也可能有些看法要表示。开始征求问题，在这里有麦克风，如果你远一点，我们也会传无线麦克风过去。现在征求第一个问题。So before the questions arrive, I would like to ask the question. As I know you have given similar talks several times in Australia, how about in other countries? Have you ever been giving similar talks to the audience in the States or in mainland China?
Yes, I have given a number of talks, particularly at the National Science Foundation conference in Chicago last year, where there's a special session designed particularly for the press, also in China, and of course I do quite a number of these in Australia, particularly for local councils who are having to deal with these issues on a day-to-day basis. They're confronted with development applications, people that are objecting to development applications, and litigation, legal issues are becoming increasingly urgent and increasing agitation.
现在有哪一位朋友到前头来直接发问？ Okay, so I have a question here. What kind of engineering constructions can prevent the sea level rise?
So we can't actually prevent the sea level rise. What we can do is minimize its impacts. And of course, the Netherlands is well below sea level. Much of the Netherlands is well below sea level. And they are protected by dikes, but the Netherlands government is very cautious about how they approach these issues. I was part of a committee about a year ago now. The Netherlands government asked us, what is the maximum possible sea level rise that we could have in the next 100 years and the next 200 years? Because they need to ensure that their levees are built to a sufficient level to protect their population. So there are options we can do. Some of these options, of course, also have significant costs associated with them, and they may also have negative impacts on the natural environment. So building a rock wall behind beaches can often lead to the loss of that beach, which is why people went to the coastline in the first place.
关于这个问题，在座我们可能可以得到很好的答案，是来自于中央大学地球科学院的院长赵峰教授。我先请你站起来，好不好？赵教授在不久之前，才有一个伟大的科学论文发表在科学杂志上头，在 Science 上。他说，人类的水坝工程阻止了海平面上升有好几公分。等一下我们请他现身说法，就是这种地球工程对于未来海平面上升或者是全球暖化的影响跟可能的风险，在这一点上的，我们还可以盖更多水库吗？我们可以在空中撒粒子，可以喷不同的气体到地球的上层来阻止 温度持续的上升吗？我先请赵峰来跟大家谈一谈他的说法。
董事长 ，John， 李家维跟我是30年的老朋友，我们在大学研究所就同学，所以他把我抓到问这个问题，其实没有像他形容那样有什么伟大的发现啊。水库这个确实让我们的海平面少上升了3公分啊，这是人类集体做了几十年的事情。当然，建水库并不是为了海平面问题，而是有其他的原因，只是附带有这样的一个作用啊。不过这个议题海平面这个议题，我想既然我拿到麦克风嘛，我就霸占一下啊。我刚从台南回来，昨天晚上就是 John Church 我们在台南成功大学斯沙龙的南部场啊，那个场昨天非常热闹，挤进了500-600人啊，2个半钟头都问题还问不完，但是必须要停止。刚才我想大家都听到的Dr. Church 对大家讲到的这个内容啊。可能你会觉得好像似曾相识，可能你觉得好像不像媒体报道这么耸动，这都由你来判断。但是我跟大家做一个可以说是一个在认知这件事情上，Dr. Church 你们刚刚听到的呢，可以说是在这个问题上人类全部的知识集中的地方，你们应该蛮骄傲听到的是正确版、完整版，而且是权威版。可能你觉得听过有很多内容不是你想象那样，但是我提醒大家您听到的就是最正确的完整版。我说权威版呢，并不是说就是 Dr. Church 就是世界的权威，并不是的。是这样，他是总结了，等于说是在这个问题上是世界上的发言人吧，他背后有成百成千的顶尖的科学家把这个事件在最近10几年之内重视，然后把它整理出来，总结在哪里呢？大家都知道 IPCC 这个每4年一个版本的这个报告这个是联合国所谓是 Intergovernmental Panel for Climate Change， 大家只要到 Google 去打 IPCC 这个所有的报告几大册就会在你面前出现当然是用英文的啦。那个报告大家应该都记得，2007年拿到诺贝尔的和平奖那一年有2个人拿到诺贝尔和平奖，一个就是美国前总统高尔先生，另外一个不是人是 IPCC 的报告。那其中有一个很重要的章节这过去了，这个几册里面几个版本里面呢，这海平面问题就由 Dr. Church 呢是一个很重要的主写人，而且他是领导人，他背后他总结了这个方向，这所有的议题大家要看到正确版、完整版就在那个里面。我知道大家一定平常都听到，不管媒体啦或者这个各个方面来到的第2手、第3手，甚至有不完全正确或者是只是这个片面正确的这些讯息希望大家能够在心理上先给它过滤，你要真的知道，就在你的网址里面打进去，真正的讯息就在里面。那个里面你看到的呢，可以说是我们现在人类当然是以科学家的眼光来作为领导我们的知识就全部都，那是我们最知识的极限了我们所有的知识都在那里面了。也许过了几年，你会发现说这个过去的有一些资讯不全甚至有一些预测可能目前真的会发生，因为刚刚 Dr. Church 一定都提到。我们现在看到真正发生是比 IPCC 这个 prediction 的预测确实是走在上限。你可以反过来说 ，IPCC 有点低估了现实的情况这个一定会发生的。科学家会第一个就承认说，对 我们当时知识去客观的来看就是这么多，我们能做的判断最多也就是这么多。目前当然也是看将来也是这样的一个看法。可是假如你在旁的地方听到的讯息，二手、三手以后的，要好好的，要很仔细的去分析理解，而不是说听到所以，然后就有一个结论说，所以 IPCC 讲的都是骗人的，绝对不是这个样子。IPCC 里面报告的，这是科学家集体的智慧给地球做的一个诊断书，目前的诊断书，里面讲到的呢，就是我们知识的极限了其他所有的东西你可以加进来，日后我们可以预测，可以知道了解的更多，但是我感觉到就是说大家能够在不同的地方听到的消息、听到的讯息很仔细的思考，不要听到人云亦云、以讹传讹这样的事情。那今天我想这个Dr. Church 呢真的他讲到这些内容里面呢可以说是我想你们可以回去跟朋友或家人说，很骄傲的说，我今天听到了这个世界我们人类知识在这个问题上最前沿的我听到了。其他讲到的其他的事情呢你甚至可以提出来纠正说，不是那样啦，我知道真的是怎么样啦，因为你今天听到了，好不好？那我想对这样的一个场子很感谢施沙龙这样的一个安排跟邀请Dr. Church 来我想这个背后有这样的一个对我们的提示这样的一个启发吧。谢谢大家。
好，谢谢赵教授，你用完你的时间了。我手上有上百个话题在这个地方。来，除了我手上的问题之外，各位可以按你前头的麦克风直接发问。有没有其他的问题？来，
谢谢李教授。Dr. Church, first of all, I'd like to thank you for the very, very informative speech you've given us, and I want to apologize for if I have actually misused the term. But just now during your speech you mentioned that because of volcano eruption that actually discharge certain kind of chemicals or particles in the air that actually help reduce the temperature. And there are actually scientists and people talking about using the idea about discharging aerosol. I think aerosol or something that you actually mentioned. That particular idea actually concerns me a little bit, and I'm wondering whether there's been elaborate discussion about that, and what is your personal view? Because sometimes I think people are trying to play God too much, and this is exactly what we're suffering right now. Thank you very much.
Yes, that's an excellent question, and I actually agree with your motivation behind the question. It's called geoengineering. There are a number of different geoengineering mechanisms being talked about. One is fertilizing the ocean such that the ocean absorbs more carbon dioxide and therefore lessens the amount in the atmosphere. Of course, that has a downside too. The ocean is already becoming more acidic, and this is a process to accelerate it. There are a number of different other options. One of the most talked about, one of the most sort of advanced, is essentially what results from volcanic eruptions. You inject aerosols into the stratosphere, and there's ways that you could do this. The genie was let out of the bottle, I think, a few years ago when one of our former Nobel Prize winners, Paul Crutzen, proposed that this issue was becoming so serious and there was so little action taken to it that one day in the not too distant future we might have to consider these options. There's been some research done on it, but not very much. There are a number of issues associated with it. One is a decrease in rainfall. We see that following volcanic eruptions. Another is the regional distributions in rainfall could be different. Does that mean one country would be open to sue another country for changes in regional climate? Who actually makes these decisions? Is it the powerful that make the decisions, or who? I personally think this is very dangerous. We are struggling to understand the current climate system and the impact of releasing greenhouse gases on it. So I would be very concerned if society went down this path. On the other side, as a scientist, I think I will be asked this question in future years. And so I think actually it is the responsibility of the science community to start to investigate these issues and what the potential impacts are. There are a whole range of issues, but there's a whole range of different mechanisms that are proposed, and I've only spoken about a couple of them, but I very much share your concern about who is playing God here.
I have some questions accumulated here concern what the major reason the Western Pacific surrounding Taiwan is the most dramatic sea rise place, and since you are here, did you have some suggestions to our governments how to face this problem?
Okay, the map that I showed with higher than average sea levels in the Western Pacific was for a particular period from 1993 to 2008, as I recall. This is not a stable pattern. This is primarily associated with what's called the El Nino Southern Oscillation phenomena. I don't know how well known that is here in Taiwan, but this is a phenomena which has worldwide implications for climate variations from year to year. It's a phenomenon that brings drought and flood to Australia, and also drought and flood to countries on the west coast of North and South America. It's a large-scale signal, and it also results in significant changes in regional sea level. And that's what that picture represents, a part of the El Nino Southern Oscillation phenomena. I could pick other periods which have a somewhat different pattern. In terms of the future, the regional distribution of sea level rise resulting from climate change, there are a number of different components. There's a component associated with changing ocean circulation, and we have models of that, but we don't have good agreement between those models, and we need to try and build confidence between those models. In addition, when you change the distribution of mass on the Earth, melting of glaciers and that water running off into the ocean, or changing the mass of the ice sheets, you actually change the gravitational field of the Earth as well. And this is a significant impact. It's probably a relatively well understood impact. It hasn't been included in projections to date, but I think it will be in the next round. And what it means is that in the near field, say if the Greenland ice sheet decays significantly, sea level around Greenland will actually fall. But in the far field, it'll rise more than the global average. And so for the Greenland ice sheet and also the West Antarctic ice sheet, the Western Pacific, including the Taiwan region and including much of Australia, is in the region of above average sea level rise, perhaps 20% or so above the global average.
在座，请。
Dr. Church, thank you for your speech. There are probably endless factors attributed to the global warming. You mentioned some of it, which we are, many people are familiar with, like reduced carbon dioxide emission and green energy and so on. I would like to point out some possible parameter and ask for your opinion whether those could be important factors attributed to global warming. One is human population. We're approaching to 7 billion, and scientists are still working on expanding human lifespan. So human population will become a problem. And the second one is military activities, like weapon production. Those kind of activities, will that be a problem? And a lot of military testing are done on the ocean, which I would assume will affect the marine ecosystem. So as a marine scientist, do you think that should be have some kind of more data to affecting the government policy? And the third one is capitalism, because everything we point out today is suggesting reducing consumption. But the modern capitalism, quote-unquote American capitalism, is encouraging consumption. And so still a lot of business still, try to point out, like some groups in the U.S. still try to influence people's ideas about global warming because they are worried this business model will be changed, and that will affect
thank you.
business.
Keep the question short a little bit.
Okay.
Thank you.
So,
would you like to answer the questions?
Let me try and go through those, starting at the end. Yes, certainly consumption is a major issue. Consumption is an issue whether it's in a communist state or a democratic state. It's the consumption that's the issue for greenhouse gases, not the system of government. And we clearly see consumption increasing around the world, independent of the system of governments. The first question was popular. Human population is, of course, a major issue. Current projections of human population reaching 9 or 10 billion by the middle of the century and stabilising. As we increase population, we increase consumption and therefore increase release of greenhouse gases. But an even bigger factor than population is the amount of consumption each of us uses. If it was only proportional to population, then we'd only be increasing our emission of greenhouse gases by less than 50%. But there's more than an order of magnitude difference in the energy consumption by rich Western nations like Australia, like US. China, mainland China, is something like four times smaller energy consumption than Western nations. India is a factor of 10 smaller than Western nations. Europe is a factor of 2 smaller than US and Australia. African nations are even less. So the actual consumption, per capita consumption and emission of greenhouse gases is a bigger issue than population. Nevertheless, population is an important aspect of that. And the second one? Oh, and the second question?
Military activities. Like, should there be some kind of international policy to reduce the military activities or reduce the production of weaponry?
Clearly we need an international agreement on greenhouse gas emissions. Getting there is going to be a difficult step. We have made some progress, but significant more progress is required. You also mentioned military issues. If we took the resources currently devoted to military use, we could solve the greenhouse issue with lots of spare change.
还有更多的问题在座各位吗？请。
Hello, Dr. Church.
I just wondering if there is anything that we can benefit from the rising of the sea level. Is there any more light side of it? Thank you.
You've got me stumped there, Ben. Can you answer that one? I actually don't know of any benefits from rising sea level. There are some benefits for particular regions for various climate change aspects. Some regions will have greater rainfall, some regions will have less. I don't think there's a net benefit, but I can't see any benefits from rising sea level anywhere in the world.
Dr. Church, I would like to have a question for you. I'm sorry.
Oh, maybe I can chip in one very short comment.
Okay.
Rather than talk about sea level, 你可以问同样的问题说 ，global change 对 global warming 有没有好处？实际上这个问题对某些人、某些地方是有好处，对大部分人可能不好处。这个好处不坏处其实是主观的。我们真的要担心的是环境在变，这个变是好是坏是另外有判断，但是这个变本身我们需要去适应的时候，这个问题就产生了。海平面也是这个问题在变这是一个关键点。
I've been waiting for somebody to raise this question, but since nobody has, so I thought I'll ask the question, which is it's a question that many people ask, especially from layman's perspective. That is, the science community seem to be split themselves. That is, some scientists do question the claim that global warming is so serious, and some go to the extreme saying that global warming is just hoax. I'd like to know what John says about this. This is the first question. And the second one is, as a very important member of this IPCC report, the IPCC does is to collect data and make predictions. That's something very pragmatic. Do you feel the pressure, or do you have the anxiety that you might be doing the wrong interpretation? Is that an issue?
Firstly, the question of credibility, is the science real? I think there's overwhelming evidence that the climate is changing. That is little disputed these days. There's a strong consensus, over 90% confidence, that the majority of the warming in recent years is a result of the emission of greenhouse gases. It is not a natural phenomenon. The natural phenomena that you can think of that the phenomena that were responsible for the ice age cycles, those changes were associated with changes in the Earth's orbit around the Sun. The climate forcing associated with those is much smaller than the changes we're bringing about by the releasing of greenhouse gases into the atmosphere. So there is no alternative explanation. There is a question which the scientific community continues to debate. Well, exactly how much climate change will we experience? How much sea level rise would we experience? And you'd notice from those graphs I've shown that there's quite a range from the top to the bottom of the projections. But the vast majority of the scientific community believe this, the scientific climate community, that those people experienced and having the knowledge to make the judgment believe climate change is an extremely urgent and extremely important issue. There are a couple of reputable scientists, quite good scientists, who raise issues, and that's great because that's pushing the community to try and improve our understanding and resolve remaining uncertainties. there is much raised in the media which is inaccurate, which is not an accurate representation of the science. It is purported to be scientific debate, but it is actually inaccurate, incorrect information which is often promulgated. And your second question was, I wanted to say IPCC does not do research. IPCC assesses research. The research is done by organisations like the World Climate Research Programme, the International Geosphere Biosphere Programme, international research agencies around the world. The IPCC assesses the research that is done. It reads the literature basically and says, what does this literature mean? The projections that come out of the IPCC are actually projections that come from the World Climate Research Programme Coupled Model Intercomparison Project. So this is groups from around the world who run climate models and ask questions, what could happen into the future? And that's then assessed by IPCC. That's not to say IPCC doesn't have a big role in this. They're very influential in determining what model projections should be done, what are the major challenges in the science that policymakers want to know about. So there's a real role for them, and it's a very, very rigorous role. But returning to your question, overwhelming evidence, overwhelming opinion is that it's real, it's important, and we need to... well, I think scientists probably might stop short of saying we need to act. That's a societal decision of how we should respond. But they would say that this is a very serious issue which society should consider.
Thank you, Dr. Church, for your speech. At the end of the talk, you mentioned the importance of bringing or partnerships between government, business, civic groups, as well as scientists. My question is there currently this kind of mechanism in Australia? And if so, could you please talk about its effectiveness? Thank you.
Well, of course, IPCC is part of that mechanism on an international level. There are various groups. So just a few weeks ago, I was at a meeting of coastal councils, and these are people right at the cutting edge in having to face issues of sea level rise and coastal development. So I was there as a scientist to speak to these people, to advise them as to what is and what could be happening in the future. So there is some movement in that direction. We in Australia have what's called the Department of Climate Change, and they're instrumental in bringing various groups together. They've recently completed what was called a vulnerability study of Australia's coastlines to say what is potentially at risk around Australia's coastline. So there are some mechanisms for that, but I believe probably insufficient.
The next question, yes.
Well, good afternoon, Dr. Church. Thank you for a speech. And from your speech, we get more ideas about the problems we are going to face in the future. Well, I would like to have a question. From your speech today, we know that sea level rise and climate changing is a proceeding process. But as for the general people, maybe like the residents in the coastal region, they might observe the sea level rise, but they may not have enough knowledge to judge what was happening. So, in your point of view, what do you think that common people should have? What kind of common knowings do you think that common people should have on these issues? Thank you.
I certainly believe that there is a need for improved communication, and in fact, not one-way communication, but a two-way dialogue about these issues, what the potential future could be, what the impacts could be, and how people might respond, and what people are actually seeing for themselves and how they would like to respond to these issues. I believe this is such an important issue that governments do need to take leadership, but that leadership will only come, I think, from community pressure. So it's really important that society becomes familiar with this issue, makes a decision about how they want the future to be, what decisions they want government to make, and to communicate that, but that requires them being informed. So we need an ongoing dialogue about these issues, and I think this meeting here is just wonderful. I haven't seen this in Australia, not to this extent anyway, and I think we need more of this type of things. Okay, I have two questions in front of me. I just wanted to add one more thing to that last comment, actually. People might argue that, well, society actually has no ability to influence these decisions. I think that's completely incorrect. Australia changed governments recently. One of the biggest issues in that change of governments was climate change. So I do believe we as society have a role to play and have the power to influence what future policy will be. So I have a couple of questions in front of me. One was the Netherlands is taking proactive action, and that's very true. Netherlands is one of the leaders. They've had to deal with this problem for many centuries, in fact. And they talked about building houses which float, and wondering whether some of these techniques would apply to Pacific Island nations. Perhaps some of them will. There's a major difference, though, between the Netherlands and a lot of the Pacific Islands, and that's the resources they have available to them. Netherlands has had far more resources than the Pacific Island. The number of people involved is relatively small, so I think some of the options are not likely to be practical on the longer term. Okay, the next question is about ways to mitigate sea level rise and climate change. We've talked about the geoengineering things. There's also a reduction in emissions of greenhouse gases, and I think I mentioned that during the talk. And essentially the last question is, well, what sea level rise could we potentially get? For the 21st century, there's been attempts to say, well, what's the maximum amount of sea level rise we could get in the 21st century? And of course, since the last IPCC report, there's been a series of papers that have come out which have all said IPCC might have underestimated the sea level rise during the 21st century. And as a result of that, they built simple statistical models which related temperature to sea level and used those to project into the future. All of those came up with higher sea level projections than the IPCC. The question in my mind is how robust they are. I personally think that we should stick to our physical understanding, but use these simple models as a warning that maybe there are other issues here and maybe sea level rise could be larger. The amount, so people have tried to estimate the maximum sea level rise we might get by 2100. Glaciologists, my glaciological colleagues would tell me, well, probably you can't get more than 2 meters of sea level rise. The ice sheets just can't respond fast enough for that to happen. What's likely on a longer term time frame, if we don't reduce our emissions, then we could see a major melting of the Greenland ice sheet. Greenland ice sheet contains about 7 meters of sea level equivalent. We might be able to get 6 of it, because some of it might retreat to high latitudes. The West Antarctic ice sheet, which is a part below sea level, it contains about 3.5 meters of sea level equivalent. Thermal expansion, you could get a couple of meters, so you could be talking about 10 or 12 meters on a longer time frame from sea level rise. There's a larger amount of ice in the East Antarctic ice sheet, which is much more stable than the West Antarctic ice sheet, and that's the order of another 50 meters of sea level rise. But we're not at this stage considering any climate change scenario that's likely to lead to a major melting of the East Antarctic ice sheet, or any major portions of it at least.
在今天中午吃饭的时候，我问了 Dr. Church， 说在地质史上最高的海平面上升到什么程度，在什么时候？他说，就他所知呢，是在4000万年前，地球的海平面应该上升到70公尺，因为比现在高70公尺，因为那时候地表上头基本上没有冰了。那这是历史记录，什么时候还会有同样的事情发生呢？科学界应该是没有很清楚的依据，可以在这时候做明确的预言。那现在我们征求更多的问题，请举手。来，请。
Mr. Church, may I ask your suggestion about tsunami? When tsunami is coming, what can we do? Just run and hide, or?
I'm not an expert on tsunamis, but yes, we can have early warning systems of tsunamis. Japan's got a very effective early warning system. It does lead to people being evacuated from the coastline, and you can have you can prevent major loss of life by having a decent early warning system and people evacuating.
关于海啸，我知道的是，在6500万年前那个小行星撞到地球的时候，当初的海啸有人预估那个浪头有1000公尺高，那大概是逃不掉了。来，在座各位。
Yes, last year, southern Taiwan experienced a major typhoon. Do you think that's one of the evidence for the extreme weather we experienced?
You can't take any single event and say that's climate change. We're always experiencing natural variability, extreme weather events. What climate change does is change the statistics associated with those extreme weather events. Hurricanes, typhoons are one of the most difficult issues in the climate change debate. The current understanding is that we're actually likely to have fewer typhoons in total, but the most severe typhoons, there'll be a larger number of more severe typhoons, and they will also have heavier precipitation associated with them. But the total number of typhoons would go down. But that's current understanding. This is a very difficult area and a much debated area.
There's something related to the global warming is the electricity. In Taiwan, we have a certain choice, something like the nuclear power plant. But as I know, in Australia, you keep the zero nuclear power policy. How do you think about that in the global view?
I think for Australia, Australia has many different options of renewable energies, particularly wind and solar. There's geothermal energy being developed, carbon capture and storage being developed. I think Australia does not need nuclear power. We can actually generate the energy that we need by other means, by renewable means. I think, unfortunately, the world as a whole does need nuclear power. There's such a demand for energy in growing places like China and India that we cannot meet that demand and keep climate change in reasonable check by just burning coal. And I think that will mean the world will have to use nuclear power in the future. Hopefully these more modern technologies which are much safer, have better storage options, etc.
在座，哎，请。
Hello, Dr. Church. I have some question here. Can we estimate that how hard we try can actually stop this? Or we can choose not stopping, but change our building or lives? Which one is better?
We're actually going to have to do both. We cannot stop all climate change, we cannot stop all sea level rise, so we will have to adapt. But if we don't do reduction in emissions, those adaptation costs will become very high, the impacts will become very high. I think we should reduce our emissions, and we should reduce them very significantly and very urgently. A common goal, a goal that was actually agreed to even at the Copenhagen meeting, was that we should try and limit warming to 2 degrees Celsius above pre-industrial values. I think that's a good target that we should aim at. One of the reasons for that target is the melting of the Greenland ice sheet. Above 2 degrees Celsius, the chances of melting of the ice sheet go up significantly. So I think we should do both of your options. It's not an either or choice.
Thank you, Dr. Church, for your speech. Sea level rise and other topics related to the climate change often makes people feel worried or desperate. According to your observation, is there anything that we can consider a good news? Thank you.
In sea level rise, I'm not aware of any good news out of sea level rise. Sorry. Other aspects of climate change, some places will actually experience increased rainfall, and that could be good news in those areas. If you live in Siberia, you might welcome it being a bit warmer. But of course there's a downside of that, and that is warming Siberia could well release more greenhouse gases trapped in the permafrost, adding to the global problem. So regionally, there may well be winners and losers from climate change. Overall, our society has developed within particular conditions. All change tends to be traumatic, particularly when it's forced upon us rather than change of our own choice. And so I think we need to be cautious and reduce both the rate of change and the amount of change.
在座还有哪个问题？来，请。
我今天来参加这个会，我这个问题是想要问李教授的，跟讨论一下。我今天来参加这个会是怀着满怀期待的，是希望这个会我听了以后，知道我们做老百姓的该怎么去面对。我不想逃，也不想跑，因为跑也跑不掉。我们台湾也很小，不过听了半天，好像都没有什么很 positive 的 news， 都是很 negative 的 news。我觉得我们好像要找出一个办法来，能够 prevent 这个 further increase of temperature。我这边就想到最近，因为我去关注这个全球暖化的事情，常常去上网看很多的资讯。我自己本身是工程师，我看了以后越看越害怕，是为什么呢？我看到最害怕的事情就是说，科学家老是跟我们说，他以前是 underestimate， 好，那现在又把数字往上调，越来越 urgent， 越来越可怕。那但是有一个好的现象，就是说我发现，好像有一个事情是可以做，而且是很容易做，但是这是一个思想的问题，就是 livestock， 就是畜牧业的问题。当我去 Google 畜牧业现在发生什么状况呢？就是现在的动物不再是像以前的牧场在青青草地上面养，而是都把它放到一个动物工厂里面去养。我们现在在台湾也看得到，鸡是养在仓库里的，牛、猪全部都养在仓库里的。那我再上去看，我们现在的全人类是68亿，但是就不要算鱼，所有的牲畜是我们的10倍。它每一只猪可以产生多少粪便，打多少嗝，所以
我先回答你问题，因为时间已经超过，好不好？你的问题，我想所有人都应该觉得无力，因为我们面对一个几乎打不败的敌人。在这种情况底下，我们聚在一起讨论的目的何在？其实我在一些学生的场合里头，关着门我会很清楚地告诉他们说，我们个人的行动对于改变整个世界来说几乎是微乎其微，但是我们聚在一起讨论这些话题的目的是希望促进我们的政府跟社会采取行动，因为只有政策才能够风吹草偃，所以我们聚在一起是建立共同的信念。你可以说互相取暖，但是取了暖之后要求政府采取行动，大概是这个意思。那你后头谈的话题，我知道我在别的场合听过，就是我们少吃点肉，
对，
我们要吃素，是不是？那谢谢，因为我们时间有限，我征求在座最后一个问题，好吗？来，那位女士。
Hello, Dr. Church. You mentioned the environmental refugees, so I want to ask that what country will be responsible to accept these refugees, and how will we deal with their settlement, job, and also because this will have an impact on the societal or economic structure of the nations that accept the refugees. Thank you.
I'm afraid I can't answer that question. I think we as society are clearly responsible, and there will be many nations which should be responsible and which should step up and accept their responsibilities. But that's clearly going to be a major decision into the future, and I'm not a politician.
Personal last question is IPCC is an ongoing organization? How frequently did you meet, and how soon can we expect the next report?
Okay, IPCC is co-sponsored by the World Meteorological Organization and the United Nations Environment Programme. It is an ongoing activity. The next report, the fifth assessment report, is being planned to come out in 2013. Working Group 1 of that report, the middle of 2013, and the final synthesis report, I think, probably early in 2014. There has been discussion about whether the current format of major assessments roughly every 6 years, with some smaller assessments at intermediate times is the appropriate way forward. That's what they've decided for the next round. But beyond that, of course, IPCC is intergovernmental. It's up to the governments to decide what they want.
经过了这2个小时，我个人的感想是，我们不必再谈将来的海平面会上升多少，因为充足的数字告诉我们，即将面对的灾难已经是庞大到无以应对。今天呢，最起码的准备工作其实都还没有展开，所以这是我们现代人必须面对的绝对困难。谢谢各位在周末来谈这么一个严肃的话题，希望在不久之后，我们台湾真的有共识来采取行动，来面对这么一个困难。谢谢大家，祝周末愉快。